Hello guys, how are you? Welcome to Space Nerd Channel. This is my first video in this channel. Make sure to like and subscribe. Before I begin this video, guys, please support me. Aim for this video is just 15 likes. So, let's begin. Sun. In this vast universe, there is no life, but solar system is the only system in this galaxy that support life. The plants depends on sun for photosynthesis. Without sun, there would be no vegetation. Sun is a large star, or you may call it a yellow dwarf. The age of our sun is about 4.5 billion years old. It is classified as a yellow dwarf star. Its distance from Earth is approximately 93 million miles, 150 million kilometers. Sun's structure and composition. Core. The core is where nuclear fusion occurs, producing the sun's energy. Temperatures here reach about 27 million degrees Fahrenheit, 15 million degrees Celsius. Radiative zone. Energy moves outward from the core through this zone by radiation. Convective zone. In this outer layer, energy is transported by convection currents. Photosphere. The visible surface of the sun with temperatures around 10,000 degrees Fahrenheit, 5,500 degrees Celsius. The corona is the outermost part and can reach temperatures of several million degrees, chromosphere and corona. Above the photosphere, these layers are visible during solar eclipses. If you ever look the sun's detail image, you may see some black spots. It's actually called a sunspot. It is cooler, darker spot of sun's surface. They are caused by sun's magnetic field, which twists and tangles because of the movement of plasma. Aurora. Is the name familiar to you? If not, then an aurora is a natural light display that shimmers in the sky. Blue, red, yellow, green, and orange lights shift gently and change shape like softly blowing curtains. Auroras are only visible at night and usually only appear in lower polar regions, northern and southern hemisphere. Do you know this phenomenon occurs because of our sun? The sun is a ball of superhot gases made of electrically charged particles called ions. These ions continually stream from the sun, called solar wind. The solar wind approaches Earth. Since the Earth is protected by its magnetic field, most of the solar winds is blocked by magnetosphere, but the ions continue to travel farthest into the solar system. Although most of the solar wind is blocked by the magnetosphere, some of the ions become briefly trapped in ring-shaped holding areas around the planet. These areas, in a region of the atmosphere called the ionosphere, are centered around Earth's geomagnetic poles. The geomagnetic poles mark the tilted axis of Earth's magnetic field. They lie about 1,300 kilometers, 800 miles, from the geographic poles, but are slowly moving. In the ionosphere, the ions of the solar wind collide with atoms of oxygen and nitrogen from Earth's atmosphere. The energy released during these collisions causes a colorful, glowing halo around the poles, an aurora. Most auroras happen about 97 to 1,000 kilometers, 60 to 620 miles, above Earth's surface. Now let's understand how the sun was born. About 4.6 billion years ago, the sun was born from a giant cloud of gas and dust called a nebula. This cloud began collapse under its own gravity, possibly triggered by a nearby supernova explosion. As the cloud collapsed, it formed a hot, dense core called protostar. Over about 100,000 years, the protostar continued to gather mass and heat up. When the core temperature reached around 10 million degrees Celsius, nuclear atoms fusion began. Hydrogen atoms fused to form helium, releasing vast amount of energy. This marked the birth of the sun as a main sequence star. The sun is in the main sequence phase for about 4.5 billion years. During this time, it steadily fuses hydrogen into helium in its core, producing energy that powers our solar system. Now let's understand the sun's future. In about 5 billion years, the sun will exhaust its hydrogen fuel. It will then expand into a red giant, engulfing the inner planets, including possibly Earth. In the red giant phase, the sun will start fusing helium into heavier elements like carbon and oxygen. This phase will last for a few 100 million years. Eventually, the outer layers of the sun will be ejected, forming a beautiful shell of gas and dust known as a planetary nebula. The remaining core will collapse into a white dwarf, a dense, Earth-sized remnant that will slowly cool and fade over billions of years. This life cycle is a common path for stars of similar mass to the sun. It's a reminder of the dynamic and ever-changing nature of the universe. Sadly, we will not be able to see this. Once the sun becomes a red giant, it will swallow our Earth. So, guys, this is it for this video. Make sure to like and subscribe to Space Nerd. If I missed anything in this video, make sure to comment it. See you guys in the next video. Bye, guys.